All right, let's do some practice problems combining like terms. Here are the problems here. Maybe I can't get them all on the screen at once, but write this down, start working on it, pause the video, come back, and then we'll go through the steps. Same with 13 and 14. Hopefully you've already gotten these written down and started working on them a bit. Let's do problem 12. We want to combine like terms first. My first step is to combine the numbers together. Or another way of doing this is to just arrange them so that the like terms are together. Again, I don't like to do all the intermediate steps, but I want you to understand what I'm doing. So I just do that here this time. So these two terms together would be a 7x. These two terms together would just be 4. 4x plus 10. Now I will move the 4 to the left side, from the left side to the right side. And then I will move the 4x from the right side to the left side, like this. And then I will divide both sides by 3, which is the same as multiplying by 1/3. So that I have x equals 2. And then, of course, I want to check my work. 2 times 2 plus 3 plus 5 times 2 plus 1. That's the left-hand side. That's 4 plus 3 plus 10 plus 1. That's 18, right? Yeah. And then the right-hand side is 4 times 2 plus 10. Oh yeah, that's going to work. 18. So that checks out. Let's do the next two. Combining like terms. I'm just going to do this by looking at it as I walk through the problem. So try to start thinking about ways to save time. 4b minus b is a 3b. So I've taken care of those two. Oh, I still have a 5b, but that's okay. I saved like half a step here in doing that like this. As I read through the problem, I start to combine like terms, maybe just one at a time, but it gives me a little bit of an advantage on a test. Positive 3 minus 8 gives you a negative 5. And that's it. So I do that in one step, just so you know. I'm reading through the problem, but I'm already combining terms as I read through the problem. Try not to make mistakes. If that's too much, just write it all down. I mean, there's no problem in taking your time. If you're getting the right answer, that's the way to do it. But here I read through 2b minus 1 minus b. So instead of writing that again, I'll just write b because I know that 2b minus b is 1b. And then that takes care of all the b's, all the b terms. And then I look at -1 and I keep reading. And I get to another -1 and I know that that's -2. So that's kind of my first step. And then I do the same process again. 3b minus 5b is going to be a minus 2b minus 5 equals b minus 2. I want to get rid of this 5, so I'm going to say minus b, so plus 5 here, plus 5 there, b, and then -2 plus 5 is going to be a plus 3. And here, I want to subtract a b. Pay attention to your signs here. Equals 3. Now, again, paying attention to signs, but also recognizing that this is a 3. This happens really often. The only thing, if you just ignored this b, well, don't ignore the b, but if you just looked at this, you would know, like, the only way to get a 3 here when you have a 3 on this side, but it's negative, is if b is a negative number. So that might inform you well enough to know that you're just flipping the sign, and so b has to be equal to -1, right? Yeah. So, before we've been doing this whole like multiply by another c kind of thing. That's just another step to help you really understand what we're doing here. But you might also just look at this and immediately recognize this happens. Cool. So of course we want to check the work. We're going to do the left-hand side first. 4 times -1 plus 3 minus, always do this, always rewrite the problem with the minus there, but then because it's a negative number, make sure to make it a negative number inside the bubble here. I see a lot of mistakes by not doing that. Personally, I've done that. -5. And the reason is because, yeah, here, -4 plus 3, but then here you have to recognize that you're no longer subtracting, you're minusing a negative number. So that's the same thing as adding. That's why. Minus, and again, when you multiply this should have been a -1. When you multiply this, you're going to be adding. All right, so let's just do this arithmetic. 3 plus 1 is 4, minus 4 is 0. So that's all 0. -8 plus 5, -3. And that's the left-hand side. Right-hand side, let's do it. I bet it's going to be -3. Just a guess. If we're correct, it will be -3. And I'm pretty sure we're correct. But you might even be given points for checking your work, or basically not getting points for not checking your work. So when you're first learning this stuff, you do need to check your work. And this looks like it works out. -1 plus 1 is 0. -2 minus 1 does in fact equal -3. So this checks out on the right-hand side. All right, last but not least, let's go. Reading through the problem statement. 2w minus 7w. So I just write -5w. 8 plus 1, so I just write 9. 3w plus 2w, okay, so 5w. Minus 1 minus 5, okay, so -6. A lot of shortcuts there, but hopefully you got the same thing. Even if you took a few more steps, it's okay. I'm already starting to see, well, okay, let's just go through. So then -9 minus 9 minus 5w equals 5w. -6 minus 9. So a negative number. And here we want to take 5w minus 5w minus 5w. Don't forget your signs here. Very, very important stuff. You get something like this where there's a negative on both sides. To me, it's easier to just multiply the whole thing by a -1. Like I'm gonna multiply, like in this step, it's such a small step that I normally do it in my head. But to me, because I know I want to find positive W, I don't even think about rewriting it like this immediately. I just want to do that to make that part easier. Get rid of the strokes, basically. There are few few written things. Okay, so W. Now I want to multiply both sides by 1/10. So that I have W all by itself. Oh no, look, it's an improper fraction. But we actually learned how to do this a while ago in math. So if you get here, don't stop. Okay, I had a little bit of a technical difficulty, but the last thing we were doing was just getting this mixed number to this improper fraction to become a mixed number. And so what I was doing was I was saying you could take the numerator subtracted by the denominator to figure out which component will be left over so that you have a 5/10 here, and then you have a 10/10 here. Because if you added it together, it would still be 15/10, but we broke it apart so that we didn't have an improper fraction. So this statement is still true, but we needed to figure out this part. We needed to figure out the 5/10 part. So that's why I did that little step in my head. Okay, so what's 10/10? 1. What's 5/10? 1/2. Which we generally write as a mixed number, 1 1/2. And hopefully you already know, we will plug that in to the original equation.